Hi guys, and welcome to today's little video on angles at a point, and welcome to my YouTube channel. Now, it's really good to have you here. I'm finding it a little bit weird. I'm sitting here talking to my own just for you. Now you say, what do you mean just for me, doing it for everybody? Well, I've got all of about 8 people watching these videos, which is great. Okay, you made the 9th. So do me a favour, spread the love in a sense of, can you let people know that I'm around? By, well, no, clicking that little button over there. That's a subscribe button. Subscribers make all the difference. Now, trust me, I am not getting rich. In fact, I make no money from these videos whatsoever. I do it for the fun. But it would be nice to know that people are watching. So why don't you send out the word on Facebook and Instagram and get your friends to come on over and watch this video and other videos here. I know you'll be bullied. Yeah, you're probably not going to want to put it out in the world there that actually you watch maths videos. But you know what? I'm hoping to make these quite interesting and funny. If you can't subscribe now, maybe a bit later on. Now, as I say, dealing with angles at a point, and behind me, you will notice as I scroll up that there is the learning for today, highlighted in that red arrow as well. Now, what are we looking at? We're looking at how many degrees there are around a single point, how to describe angles and write them and display them, because much of maths is about the language you use. And if you can understand the language, then pretty much life is good. So if I say ni hao, or I say bonjour, or if I say guten Tag, then hopefully you'll realize that I'm speaking a number of different languages. Ni hao, hola, bonjour, what did I say the other one? It was guten Tag. They're all different languages and all of them mean hello. Now, the only way you're going to know that is to learn what the words individually mean. And then we're going to put them all into practice with some pretty nifty examples. And as I normally do, let's recap the fun and excitement that is angles. I know there are a number of videos now on my channel that deal with this stuff, and it's building up bit by bit by bit. So why not watch the previous videos and then come back to this one if you haven't already. And we've already dealt with the idea that there's 180 degrees inside absolutely any triangle. And then we know that there are a number of different names for triangles out there, but it doesn't matter. 180 degrees in a triangle. There's 360 degrees in a quadrilateral, and there's an example of a quadrilateral which we can split up into 2 triangles. And if each triangle has 180 and 180, then we know that in total the angles inside that thing must be 360 degrees. And the thing I've just done here, ladies and gentlemen, can actually apply to all polygons. And you're going to say polygon, and I'm going to say yes, my parrot has left. Parrot has left. See what I... No, I'm sorry. There's a video coming on polygons as well, but not parrots that have left. And we also know that if we have a straight line split up into all sorts of different angles, then all of the angles on there make 180 degrees, so long as it's a straight line. Yeah? So what more do you think we could need to know? Well, as I say, language, language, and language. Maths confuses you. Have you realized that just to talk about when we multiply 2 numbers together, we use the words like times, you know, not time, times, or we use product, find the product of 2 numbers. Why? Well, actually, there's a guy called Barry in Australia who I swear is actually in an office, and he's probably got no windows. He probably has just one light in there, maybe a candle. He's undoubtedly got bad facial hair and wears a white lab coat. Probably got a bit of a dribble. I don't know, you know, no friends. And I think this is some job to actually turn around and find all the confusing ways that we can write about mathematics. And I swear he gets pleasure out of this. It's funny to him. He's like, ha 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 ha. Yes, I think we'll find 15 different words that just mean to add together. I mean, think about it. Add, sum. I'm sure there are others. In fact, if you can think of the others, put them down in the comments below. Can you think of other random words that we use to describe maths? And I swear, there's a secret society out there that basically says, let's make maths hard for kids. Well, I'm here basically to dispel and break apart that secret society. And hopefully that's exactly what I do with these videos. Yay! But let's have a look at the different ways we name angles. And you're going to say, what do you mean different ways we name an angle? Well, imagine I have this angle here, and let's put it there. Now, first things first, I can actually label this using letters A, B, C. Right, so I've used ABC, which means I desperately want to burst into Michael Jackson. But I won't, for copyright infringement purposes. So, first things first, we can call this angle ABC. Now, do you notice what I did there? Angle, there's an angle sign. We can call it actually angle CBA, believe it or not. Yes? Which is just random because I'm just putting the letters the other way around. We could call it angle B, where we just put the letter B. We can put a little B here, for example, with a little degree sign to say B degrees. How else could I do it? I could do angle ABC wearing a little hat. I mean, there are so many different ways of doing this. It's almost crazy. Barry was working overtime that day. He obviously had caffeine. It was great. But we need to realize that when we label angles, and obviously there's the B degrees there as well, we've got to go with what the question's trying to tell us to do. So if ever they use capital letters, where there's 3 of them, we're generally talking about an angle. Yes, when there's 2 letters together, for example, AB, in that situation there, we'd actually be just talking about the line that connects A and B together. If we had A, B, C, D, for example, think of a shape that would have 4 vertices. Oh, you've done it again, Barry. What's a vertex? It's a corner. All right. So I'm looking there at the idea of ABCD could be a rectangle, and we label it. We choose a corner, and then we generally work around clockwise, putting the rest of the letters. Well, okay, maybe Barry was having a good day here. At least he didn't turn around and come up with some random mathematical formula. So ways we name angles are there just to confuse you. But what about types of angles? Well, this is stuff from year 6. You know this stuff backwards. An acute angle. Now, this sounds really, really weird. I'll probably get away with it in the United Kingdom, but acute angle. Well, if you walk down the street and see someone who's looking pretty cute, the chances are they're literally 1 pound above organ failure. Because unfortunately in this society, we decide that everybody needs to look really thin. Trust me, the reason you don't see below my chin or my neck is because, yep, this is not thin. But the point is, you go, oh, acute. And an acute angle falls between 0 and I'm going to say 90 degrees. It doesn't really include 90 degrees. And so this would be an example of an acute angle, something between 0 and 90 degrees. I wonder if I was to ask you to estimate the size of that angle, what you think it would be. That's actually an important skill coming up as well. A right angle. Well, we know what a right angle is. That's awesome. That is 2 lines like this that have that little sign in between it. So whenever you see that little square in the corner, it means a right angle. Obtuse sounds a little bit like obese, a little bit of a large angle. Now, obtuse is exactly that. Obtuse is between 90 and 180 degrees. So this here would be a perfect example of an obtuse angle. Maybe that was 135 degrees. Now, I'm not being sizist here. As I say, if I look down at this moment in time, trust me, the gym is a long, long way away. I don't go swimming anymore because actually that would just terrify people. So obtuse goes between 90 and 180 degrees. A straight angle, I have to say, I've never heard of that before. I'm like, a straight angle, what is that all about? It's just talking about a straight line. And what it's saying is that if I had a straight line, I have 180 degrees. See how this is building up? A reflex angle. Ooh. Now, if I was flexible, I'd probably have to bend backwards. My spine won't let me allow that because, obviously, why would any of us want to bend backwards? But a reflex angle, I think very much like that. It is an angle that is between 180 degrees and 360 degrees. So that large angle, yes? And a revolution angle. I have to say, I was talking to my kids today in my lessons and I was going, revolution angle, I swear that's an Australian thing. If it's a British thing and you're watching this United Kingdom or Australia or India or America, I'm beginning to hit it big in America. Spread the word, spread the word. Donald Trump's allowed me in. The whole point is, where's a revolution angle come from? Yeah? Right. But a revolution angle is, funnily enough, when I go all the way around it in a circle, or I revolve, like a revolving door, and a revolution angle happens to be 360 degrees. So that's language that we need to know. But there's even more. I mean, come on, Barry. Chill, mate. And then we get to complementary angles. Now, don't we just love complementary angles? Oh, yes. They walk up to me in the street, and they go, do you know what today, MaffsGuru? You're looking fabulous. You're fabulous. And I'm like, what do you mean you're looking fabulous? Firstly, in my deluded world, angles don't actually speak to anybody, and nobody ever pays me a compliment. Literally, no one. No one sits and goes, you know what, MaffsGuru, love the videos. No one goes, MaffsGuru, you're looking ace today. MaffsGuru, keep it going, because there's only 8 people watching. A complementary angle, sadly, is not that. If someone's going to pay you a compliment, it has an I in it. Complement means something else. So complementary angles are basically angles that add up to make 90 degrees. Oh yes, so if I had 40 degrees there, and what would that be, 50 degrees there, then they are both complementary angles. They're complementing each other. The 40 is saying to the 50, oh, you're looking fabulous. Fab, 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 fab. That's when they add up to 90 degrees. And then we have these things called supplementary angles. And what on earth is a supplementary angle? Well, where a complementary angle adds up to 90 degrees, a supplementary angle, funnily enough, adds up to, 180 degrees. So a supplementary angle adds up to 180 degrees, or two supplementary angles add up to 180 degrees. And there are always questions in exams that go, give an example of a supplementary angle, and you just go, two angles that add up to 180 degrees. Not particularly difficult, but it's all language. Now, vertically opposite angles I think are awesome because this ties back in to a lesson I've done on physics. And you're going to say, physics? That sounds rude. And I'm going to say, yeah, no, it's not. Physics deals with angles that are either parallel or, opposite each other. All right, so I've dealt in a previous lesson with the idea of what I call the Z rule, which basically is nothing more than when you see two parallel lines, and that's got those little arrows on them, angles inside, when you can make a Z, and that little slanty line there makes a Z, are exactly the same. So if I put a dot there and a dot there, that means that those angles are exactly the same size. So that's my Z rule. One of the ones that we also like to deal with are called I call them the X rule, only because it's like an X, no deal. But the point of it is they are vertically opposite angles, which is a bit weird. But this means that this angle here and this angle here are actually exactly the same size. So if that was 60 degrees, then this is also 60 degrees. Now, bearing in mind we now have two straight lines there, it means I can find this angle here for my dot, because I know that angles on a straight line add up to 180 degrees. Here is a straight line, so that must be 120 degrees, which must mean that this angle here is also 180 degrees. Why? Because they are, vertically opposite. And I'm going to say, probably not in this situation, they're probably horizontally opposite, but weirdly we call it vertically opposite. See what I mean? Barry's at it again. So whenever you see an X, the angles either side of each other are exactly the same as each other. They're just called vertically opposite angles. And one that, again, absolutely love are these. Now, again, you're going to turn around and say, oh, you've drawn an X, vertically opposite angles. Yes, but what I'm also going to tell you is that these lines have 90 degrees between them. So I'm going to do it that way or that way or that way. It doesn't actually matter, really. But when they meet or when they cross at 90 degrees to each other, we say they are perpendicular, right? So parallel lines like this never ever meet. Perpendicular lines like this and always will have 90 degrees, which actually says that that angle there is 90 degrees, that angle there is 90 degrees, and so that angle there is also 90 degrees. And this is going to actually be really important because what do you notice? If I was to draw a circle around this shape, what do we know about angles in a circle, otherwise known in this wonderful country as angles in a revolution? Yes, 360 degrees. And I just want to check, does 90, 90, 90 and 90 add up to 360 degrees? Well, I should cocoa. It does indeed. And so, ladies and gentlemen, one of the fabulous learning for this lesson, other than all the complementary and supplementary stuff, is that angles around a point always add up to 360 degrees. Knowing that information, we can pretty much find anything. So let's do a basic example. Here's a point, and now, you could think this was a squash spider, but I tried to crack that joke today, and unfortunately my group were like, but a spider has 8 legs. And as usual, my humour just fell way flat. So, here's a basic example. Let's say that angle there is 70 degrees. Let's say that's 60 degrees. Let's say that's 50 degrees. Let's say that's, 50 degrees as well. And I'm going to write down the value of x. Now, whenever we see the x, that's the thing we want to try and find out. So, having drawn my diagram, which is really important in mathematics, a quick diagram, I'm now going to do my working out. And as I do in all of my videos, I'm going to show the full working out. So, I know that 70 degrees plus 60 degrees plus 50 degrees plus 50 degrees plus x must be 360 degrees, because again, if I was to draw a line around all of those, I have a circle. They're just inside that circle. So 50 plus 50, I'm going to simplify to 100 degrees. 60 plus 70 is 130 degrees. plus x is equal to 360 degrees. Notice what I'm doing is breaking down each line bit by bit. 130 plus 100 is 230 degrees, plus x is 360 degrees. I want to get rid of the 230, so I'm going to take it away from both sides, which gives me the wonderful value of 130 degrees. So ladies and gentlemen, 130 degrees. Now you're going to look at that and go, it doesn't look 130 degrees. And I'm going to say, no, don't worry about it, because remember, diagrams are never drawn to scale. Yes? So that was nice and easy. What about this one? What's this strange symbols business? Well, yeah? So there's another example with a strange symbol. So let's say that's 40 degrees. That's, I don't know, 100 degrees. That's 60 degrees. And I'm going to put, let's call it something else like y, because we don't always have to have x for the letter. Do you see the point? Well, they all meet at a point, this squash spider. And so knowing that, and knowing that they're effectively inside a circle, and that's a really bad circle, but we'll go with it, means I can use that 40 degrees, plus 100 degrees, plus 60 degrees, plus, hold on a moment, I've got that little funny symbol. What's this little funny symbol all about? Oh, perpendicular, 90 degrees, and plus y gives me 360 degrees. So we've got 40 plus 100, which is 140 degrees. 60 and 90 is 150 degrees. Plus y is 360 degrees. Add those together gives me 290 degrees. Plus y is 360 degrees. Take away 290 from both sides. And y gives me a grand total of 70 degrees. The crowd goes crazy. And so is Darren going a little bit crazy because he's imagining crowds. We can use algebra as well. It doesn't actually matter. So I could have this here. I could say, well, that's x, and that's 2x, and that's 2x, and that's 3x, and that's 2x. And it's going to say, find the value of x. Now, funny enough with algebra, people tend to get a little bit sort of weirded out by it. But I wouldn't, because algebra is just another way of standing for numbers. Now, what did we do when we had numbers? We just took all the numbers and added them together and put it equal to 360 degrees. Well, I'm going to do the same thing here. So I'm going to say I've got x plus 2x plus 2x plus 2x plus 3x is equal to 360 degrees. Add those all together. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 x's. Is equal to 360 degrees. Well, if I know that 10x is 360 degrees, I can divide both sides by 10, which gives me x is equal to 360 degrees divided by 10, which gives me 36 degrees. So I can combine algebra and this angly stuff. Wow! What about using a compass? Now, I've got here, never eat soggy Weetbix. All right, now we don't say that in the UK. It's like never eat shredded wheat. All right, now if you're in the UK and know what shredded wheat is and you like it, you're weird. Just moving on. Me, shredded wheat, I'd rather eat straw. In fact, I think it is straw. I reckon there's a whole conspiracy out there about that as well. But anyway, if we have a compass, then we know that north, east, south, and west. And if you don't know what I'm talking about, never eat soggy Weetbix. Never eat soggy Weetbix. And again, if you're in the UK watching this, I know Australia calls it Weetbix. We call it Weetabix. I don't know why Australia decided to drop the but I think Weetabix, nice. Weetbix sounds weird. Long discussion. And then what we have is we have these little points halfway between each of these main compass points. So this one here is northeast. This one is southeast. This is southwest. And this is northwest. Now, why is a compass important to me? Well, because funnily enough, these also have angles associated with them. So north is generally 0 degrees. Northeast is 45 degrees. Then we have 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, and then 300. And so we've got 45, 315 degrees. Going back to 0, which is also 360. So the question might state, for example, you know, what angle is it between northeast to southeast? And what they're really saying is just work out the difference between, well, northeast is 45 degrees, Southeast is 135 degrees. And what is the difference between the two of those? Well, there we go. There's another word. Take them away. Difference. Same thing. So 135 degrees minus 45 degrees gives me 90 degrees. And lo and behold, it just so happens there are 90 degrees between those. And the last example I'm going to have today is about using time. Now, clocks are fabulous things, right? We can use clocks to do angles. So if we have the time 12, and then there's 3 here, and 6 there, and 9 there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. We can actually use our clock to draw angles. So, for example, between 12 and 3, it just so happens to be 90 degrees. Between 12 and 6 would be 2 lots of 90 degrees, which is 180 degrees. And you'll say, well, hold on, what's that got to do with anything? Well, imagine they wanted you to find the angle between, say, 12 and 1. What angle the hands make between 12 and 1. Well, we now know that our clock could be split up into how many different slices. All right, so it sort of goes back to fractions. Well, there's 12 hours, which means there must be 12 slices. There are 360 degrees in one whole circle, so we know there's 360 degrees around there, and we now have 12 equal slices. So if I divide that by 12, then I know that the angle between each part is 30 degrees. Yeah, so 12s into 36 go 12, 24, 36, so that's 30 degrees. So I now know each of these little angles here is worth 30 degrees. So if I wanted to now know the time between 12 and 1, I can simply write 30 degrees. What about the time between, I don't know, 12 and 5? So if I had to do between 12 and 5, well, I've got 1, 2, 3, 4, 5 lots of 30 degrees, which is 150 degrees. And that, ladies and gentlemen, pretty much brings this lesson to an end. We've done angles at a point. Now, you're going to say, really? And I'm actually going to say to you, that's about as easy as it gets. So long as you realize that angles around a point are 360 degrees. So long as you know that we can name angles in various different ways. The different types of angles, the acute, the right, obtuse, straight, reflex, and revolution. Complementary, supplementary, vertically opposite, and perpendicular, and actually put all of that into place, like I'm showing in the example behind me, then realistically speaking, you know everything. And this is like year 8 work here in Australia. People think maths is hard. Barry, sorry mate, I'm going to do what I can to dismiss it. All right, ladies and gentlemen, I am done for this lesson. As ever, it is fabulous seeing you, and I am delighted that you've actually made it to the end. I wonder if you've actually made it to the end. Do me a favour, leave a comment below. If not, yeah, I'll have to make these shorter. All right, if you haven't already done so, please do me a favour and subscribe by clicking that little circly thing over there. And if not, hey, there's another video loading for you to watch if you so wish. All right, I'm done. Have an awesome day. This is MaffsGuru signing out.